For years, mosquito-borne diseases like malaria, dengue, and chikungunya have been a major health challenge in the beautiful southernmost provinces of Thailand. And health officials have. Well, they've got mountains of data, collected over more than a decade. And yet,
You've got to wonder, right? It's a puzzle that's been bugging public health experts for a while. With all this information, why can't we just forecast where the next big outbreak is going to hit? Well, the answer, as it turns out, is a fascinating statistical surprise.
That's right. The problem isn't that we don't have enough data. The problem is we have too many zeros. For years, this statistical silence has been throwing a major wrench into all the models that are supposed to predict how these diseases spread.
okay, so let's dig into this. What does it actually mean for data to have too many zeros? I know it sounds a little strange, but it is a huge hurdle in epidemiology.
Think about it like this. Your traditional prediction models, they're looking for a signal, right? The number of cases. But when most of your data is just silence, 0 cases here, 0 cases there, the models just get confused. They can't tell the difference between a place that's genuinely safe and a place that's just the quiet before the storm. That silence, it actually hides the real risk.
So how do you solve a problem like too many zeros? Well, a team of researchers in Thailand came up with a really brilliant idea. Instead of asking one big, complicated question that the data keeps getting wrong, they split it into 2 simple, targeted ones.
And this two-step model is just beautifully simple. First, it asks a basic yes or no question. Is there any risk of the disease showing up here at all? That's the occurrence. Then, and only if the answer is yes, does it move on to the second question. Okay, so how bad is it going to get? That's the intensity. This simple split lets the model completely ignore all that statistical silence and just focus on where the real danger is.
And this is where it gets really cool, because asking these 2 separate questions reveals these incredible hidden patterns, both in space and over time. So let's see what this powerful new model found for 3 of the region's biggest disease challenges.
First up, malaria. It's a huge concern, especially in the more rural and forested parts of the region. The model sifted through over a decade of data to see who's getting infected and where the risk is really concentrated.
And right away, the 2-step model reveals something absolutely crucial. For malaria, the group that's most likely to get the disease, that's young adults, people working outdoors, is totally different from the group that gets the most severely sick from it, the elderly. And that's a huge distinction. Knowing who to warn about getting infected versus who might need a hospital bed are 2 very different public health problems.
Spatially, the model gets incredibly specific. It pinpoints the highest risk for both getting and suffering from malaria down to these mountainous, forested subdistricts in Yala Province, right there along the Thai-Malaysia border. This lets you target prevention efforts exactly where they're needed most.
All right, now for dengue fever. And the model tells us a completely different story here. See, unlike malaria, which kind of hides out in the forests, dengue actually thrives in more populated areas, and its risk profile looks totally different.
With dengue, the model shows this fascinating V-shaped pattern for risk. While school-aged kids are the ones most likely to get infected, the severity is highest at the 2 extremes of age, in young children and then again in the elderly. This gives health officials 2 very distinct, very vulnerable groups to protect.
The model also picked up a rhythm to the disease. It confirmed a really predictable 3-year cycle for major dengue outbreaks. That's huge. It basically puts a timer on the next potential crisis, and that gives officials a crucial window to get ready.
The map for dengue looks different too. Instead of being focused on forests, the risk is high in densely populated urban centers like Hai Tai City in Songkhla Province, and also in specific rural areas in Narathiwat, a totally different geographic footprint from malaria.
So the third disease, chikungunya, is known for causing this awful, debilitating joint pain. And what the model found here was a really remarkable long-term cycle in its outbreaks.
I mean, this is crystal clear. The data shows 2 massive outbreaks, and they're separated by almost exactly 10 years. Discovering a decade-long epidemic cycle like this, that's a massive breakthrough for any kind of long-term health planning.
And look, the risk profile for chikungunya, it kind of echoes what we saw with malaria, right? Again, it's the active adolescents and working-age adults who are most likely to catch it. But once again, the burden of severe illness falls hardest on the elderly.
And here's another critical insight. Risk isn't static. It moves. The model showed that while the first outbreak was really centered in Narathiwat Province, the hotspot for the second outbreak, a decade later, had actually shifted over to the neighboring province of Pattani. This proves you can't just keep focusing on old hotspots. You have to predict where that risk is moving next.
So what does this all add up to? I mean, this isn't just some interesting statistical game. By revealing these hidden patterns in space and time, this model gives us a real roadmap for a smarter, more targeted public health response.
So, the bottom line is this. You can now tailor your response with incredible precision. You can focus awareness campaigns on young adults for malaria, but prepare your hospitals for severe cases in the elderly. You can target mosquito control in the forests of Yala for malaria, but then shift to the urban centers of Songkhla for dengue. This is precision public health in action.
And hey, don't just take my word for it. As the researchers themselves conclude, this isn't just theory, it's a practical tool. It's designed to empower local health officials to make better decisions, to prepare more effectively, and to respond with precision when, not if, the next outbreak happens.
It's just a really powerful idea, isn't it? By just reframing a complicated problem, we can find these elegant solutions that were hiding in plain sight the whole time. It really leaves you wondering what other complex challenges, whether in public health or somewhere else entirely, are just waiting for us to start asking the right, simple questions.